Good evening, champions. My name is Toby K. I made a contribution for V4Gamma called GameAudioPlayer, and this is a tutorial video about how to use it. I made GameAudioPlayer because implementing audio is something that always brings a lot of impact to projects, but as a developer, it's a task I always underestimate and come to quite late in a project. It's true that just playing some media is not so hard, but I always run into little gotchas to do with managing player instances and loading blocking the main thread. VL.GameAudioPlayer is meant to be some tools for solving these problems, so in future I can spend more time on the content side of sound. Compared to VL.Audio, the audio pack that ships with V4Gamma, GameAudioPlayer has a narrower focus on just playback, but it aims for a higher level and more convenient abstraction. GameAudioPlayer only plays sound to the default sound device. If you want to manipulate live sound, use ASIO devices, fast Fourier transform, all that fun stuff, then VL Audio is your pack. But if you want to take sound from other software and just play it, then GameAudioPlayer could be a simpler and faster way to achieve that. In this video, I won't go through every single help patch. I think many of them are self-explanatory. I'll use the video to focus on things that are better explained in this medium, like the integration with other software and some of the more complex parts of the implementation. But first, how to install it. I have the current stable V4Gamma 2021.4.12 open. VL.GameAudioPlayer has a NuGet, so click up here in the top left, press Manage NuGets, command line, and you want to type NuGet install VL.GameAudioPlayer. Before you press enter, just give a short thought to security. NuGets are a great way to get live code from others on your machine, but that could be a vector for something malicious. It would be very easy for a malicious actor to clone a legit package and just put in, say, a tiny difference in the name. So, just have a think. Is this legit? I obviously think I'm legit, but to provide more security, you could check out this package on NuGet.org and GitHub, where I'm Toby K Light, and on v4.org, where I'm Toby K. I just want to encourage everyone, anytime you see NuGet install instructions, ask yourself, could there be something fishy here before I pull live code into an environment that could have admin privileges. Once it's installed, you should get the help patches here in the help browser. Let's start at the start. First thing you need is an instance of Game Audio Host process. You should only need one in your entire app. This receives commands and manages player instances. Then you need to have a folder with audio files that you select here. One gotcha that can be confusing is that the default path I/O boxes in V4 are in file mode. If you want to select a folder, you have to right-click them, press configure, and change it from file to directory mode. Here is the sample folder that ships with the pack. If we go into these subfolders, we can find the audio files. But you can also put them on the root. It supports many formats, but sadly not MP3 due to an underlying library limitation. But convert your MP3s to OGG and they should work well. You can use subfolders in the audio folder to organize your files. However, ensure the file names are unique no matter which folder they're in, because it's the file names that will become the media keys you use to select media for each command. Back in V4, hit rescan if you changed anything, and if it's found some media it can play, you'll see them listed here. These are the media keys. Each key is the unique string you use to trigger this media on the play commands. All these media type settings are just defaults, and they can be overridden, often using hidden pins on the play command. It's also possible to put any media key in any play command. Even though these are prefaced with music, that's just for my organizational reference. They can be put in the sound effect command if you wish. Now finally for some actual sound. Using these reactive commands, play sound effects, play music, and stop all media, I can tell the Game Audio host to do some things. You can find the full list of commands in the Node browser under Game Audio Player, Game Audio Player command. There's another quirk of the V4 UI to know about when you are connecting these. If we look, you can see the types of the play commands and the stop command are different. If I delete that link, you'll see the merge node is taking the common type of the two play commands, observable play load request. When I try and connect the observable stop request, you'll see it doesn't go green, I have to hold space and left click to force it, in which case the merge takes the common type observable iGameAudio request. It's called GameAudioPlayer because it operates on three distinct categories often seen in game sound design: sound effects, music, and dialogue. To be honest, dialogue is there, but I didn't have a use case for this during development, so it operates with the same defaults as the music category. If you use dialogue and think it could have a different default setup, let me know on the GitHub. Let's take a closer look at adding media. So the basic workflow is just to add files to the folder like we've seen. The advanced workflow is to also include additional metadata with a TSV file. TSV stands for Tab Separated Value, and you can export this format from standard spreadsheet software. I'm just using Google Sheets. In the example folder that comes with the pack, you can see a TSV file as well as the spreadsheet it's been generated from. There are a few reasons this advanced media import workflow can be useful. The first reason is if you are working with a composer, it becomes a single source of truth to agree on the media keys. As a developer, you could even set up the media keys in advance as a list of what you need. You can also include more details for communication purposes, like for example, the category and comment columns are not part of the data that will be read, they're just here for information. The second reason to use a TSV file is it allows you to create many media keys out of just a few files. You can see here all of these media keys point to the same files and they just have different start and end times. Why is that useful? Because in most audio programs, it's a pain to export multiple files. It's much easier to export a single file. And it's much easier to work with a single file to do tasks like applying normalization, mastering, or any kind of treatment to make sounds consistent. The third reason to use a TSV file is to notate sections of music as loops, which I'll show you how to use a bit later. There are some technical details with the TSV file. This is all in the help patch as well. The column names must be in the first row. You must use these exact names. However, the columns can be in any order, and if you add extra columns outside the spec, that's fine. The only two columns you must have are media key and file path. The others are optional. For any value you don't want to use, just leave it blank. Don't write 0 unless you mean 0. You can also include whole blank rows just to break it up visually. If media key is blank, it will ignore the row. The paths in the path column are relative paths inside your audio folder. You can enter the start and end times a few ways. By default, it's seconds, so that's 69.5 seconds, or if you use a :109, that's 1 minute and 9 seconds, 69 seconds. If you include a value in the BPM column, then start and end is interpreted as bars, and that assumes you've got 4 beats per bar. So that's starting bar 24, ending bar 25. The bar values start at 1, not 0. A little bit confusing for programmers, but that's how it is for composers in the music software. So if I write bar start of 1, bar end of 3, that's doing this loop from 1 to 3. The idea is your composer can just read off their BPM value and the bar values and put those straight in the spreadsheet. You'll notice I've used the same BPM and bar notation for the sound effects as well because I also process that in Ableton, and in this case it's easier to use those than the seconds values. The next big topic to understand is preloading versus streaming. You don't need to preload to get started, but it can be useful later on. Basically, the underlying library SFML has two ways to play sound. You can either open files on the hard disk and grab bytes as you need them, so-called streaming in this context, or you can preload the whole piece of media into memory. The difference is basically preloaded media is looped more accurately and plays with a tiny bit less lag. The downside, of course, is your memory usage goes up. To enable preloading, there are some hidden pins on Game Audio Host. So, what should you preload? I would preload anytime you need to use loops, and I would also preload sound effects that you want to play with the minimum lag possible. To save you some memory, you can update this preload list while your app is running. For example, perhaps you only need the musical loops for the boss fight in the boss level. To do that, simply change this list and hit do preload. When preload in progress is false again, that means everything here has been loaded. Let's talk about some edge cases with preloading. It's not a huge problem if you play a loop before preloading is complete, it will just stream the file. It might be a tiny bit janky on the loop restart, but it's much better than silence. You will get a warning in the log, and next time you request play, it will swap in the preloaded version. It also should not screw up playback if you remove something from the preloaded list while it's playing. Preloading loads uncompressed sound data into memory. So here's a pro tip, mono files will take up half the space of stereo files. You can also preload by tag from a command. That's what this column in the TSV file is about. It's pretty simple with a good help patch, so I won't go through it now. Okay, let's see some of this looping in action. So, for a perfect loop, we have to meet 3 requirements. The first is that the audio is exported at a consistent BPM and with the first frame of the audio starting on the first beat. This is what happens by standard when you export from software like Ableton. If I select this as an export area and it starts at 1, file export, it's going to render from exactly that beat. But what this does mean is you can't just drop in any MP3 file from your old hard disk that you converted to OGG, of course, because these will generally have an irregular amount of silence at the start, and if it's not electronic music, there's a good chance it's not at a consistent BPM. In that case, you could use software like Ableton to warp it and prepare it, but that's out of the scope of this video. Second requirement for accurate looping. Media has to be set up in the TSV file with a BPM and start and end in bars. Third requirement, media should be preloaded, then it's going to play and loop most accurately. To enable looping, on the play commands is an optional pin, loop count. I probably could have called loop count play count, but I wanted to leave the word loop in there so it's obvious it's about looping. A loop count of 1 is actually not looping. That means it only plays once. A loop count of 2 or more means it plays that many times. A loop count of -1 means play forever. So what does a loop count of 0 mean? A loop count of 0 also means play it once. Technically, it should probably mean don't play at all, but I don't think there's any case where you'd send a play command and not want it to play. You can also update the loop count of playing media with the set looping from now command. But an important detail is that it sets looping from now as if the loop that's playing now is once again the first. So if we see what that does, it's playing 2 and then set it to 1. That means it's going to finish because it says, oh, you only want to play 1 and we're in that first one now. Now let's look at what happens when you play multiple pieces of music. There is a built-in assumption with music that you actually only want one piece of music playing at a time. And so by default, if you request another music track, it's going to work out an elegant way to transition. But it is just a default. You can override all this behavior. The usual way it gets between pieces of music is with this option that's on by default, auto fade out others, and there's a time that's there as well. So what does it look like when you hit play? So you can hear, as soon as I play the other one, it starts fading out the one that's already playing. You can also add delay parameters and a fade up time to the media that you're triggering. These parameters combine to give you control of the crossfade. You can either ensure it fades to silence before the next one fades up, or that it does a kind of laconic crossfade and you definitely hear both media overlapped. Another function to talk about quickly here is retrigger. Retrigger means if I hit play again for the same media, it restarts from the start. This is off by default for music, because almost always you don't want a 3.5-minute music track to just jump back to the start. Now, let's look at the play music in sequence functionality. I'm quite happy with this. So for this to work, your music loops need to be set up same as we were talking about earlier, plus enable this optional pin on the play music command try play next. If you use Ableton, This is similar functionality to triggering clips in session view. Let's see it in action. So let's play this first one. And then if I hit play on the second one, you'll notice it doesn't play as soon as I send the command. It should wait till the correct musical time. And notice how it's exiting on the next bar change. I'll now go to this other one down here, which is a bit louder. And you'll notice it's a 4-bar musical phrase, and it's going to take 4 bars before it'll exit. Meanwhile, these two exit every single bar. Let's stop it. There are 2 ways that it knows when to exit to the next clip. The first is when it simply reaches the end. The second is through the TSV file, there's a column can exit every X bars. And for example, both that beat A and beat B have exit every 1 bar. That longer musical phrase has exit every 4 bars, which is how it played the whole phrase. What's useful about this is it allows you to make a longer piece of media with lots of variations, so your background music doesn't sound too repetitive, but still have frequent exit points. So when it's time for the music to change, you don't have to wait too long or wait till the end of the whole sequence in order to change it. For example, here beat B is actually 8 bars long with a lot of variations, but you can exit every single bar. There is also a special command here, play music next cue, that allows you to supply a list of media. In this case, you can supply a loop count, but note the loop count only applies to the last thing in the list. The earlier items always play once. What is this command for? What this allows you to do is say that the intense part of the music should always be prefaced with certain build-up parts. It also has a smart bit of logic. If it's already in one of these parts, it will just add the next part in the list. It won't go through the whole list again, although you can turn that off with this special option. Let's see that in action. So I'm in beat A, and it goes on to beat B, and into main group. An important detail with try play next is how does it know that 2 media keys are part of the same song? Because they reference the same path in the TSV file. If you try and play music that's not part of the same song, it's going to use the auto fade parameters. What this adds up to is that even if you have a mix of media that should play next and media that shouldn't, if you just always have the options try play next on, retrigger off, auto fade out others on, then it's always going to work out an elegant way to move forward. So these can play next. Gotta wait till 4 bars. This has to fade, so it'll do the fade. The idea is that this is a golden set of options that simplifies heaps of cases for your music triggering logic. You can blindly request the music from anywhere in your app without having to care about the currently playing state. The game audio player will work out an appropriate transition. This isn't going to cover every single use case, but I think it should be a decent off-the-shelf solution for many projects. There are some more edge cases you can run into with all this, like what if you request play again for something that's already fading out? You can see all of those in the reference help patch, play cases in detail. If you're confused about some behavior, you can probably find it in here. For the last topic in this tutorial, let's go all the way back to the commands. These little commands are stateful processes that create their own observable. Ideally, you use them in your own stateful context. If you put them in a stateless context, like an operation, this means the observable is going to be recreated every frame. If I put a standard reactive node on that, you'll see this changed pin is high. This changed pin is high, and it's using a little bit more performance than it otherwise would. Now, if you only do this a few times around your application, then it's probably not going to be a problem. But if you're using a lot of commands all over the place, then it might be worth looking at the advanced architecture. This advanced architecture will allow you to send commands in any context, stateful or stateless, with slightly better performance. Basically, if you enable browsable packages in settings, then you'll be able to look inside any of the commands and you can see the record type that is actually sent on the observable. You can access these types if you turn on advanced in the Node browser. It's already on here. Play, load requests, any of the other request types are there. Then if you set up, let me go back to the advanced architecture here. If you set up a single observable, I'm using channel, but you could use something else, then you can send those records to send commands directly to the game audio host. If you're using commands of different types, then make sure your channel is the common type iGameAudioRequest. If you don't know what the hell I'm talking about with observables and things, then you don't need to worry about it. Probably the basic architecture is going to work great for you. Reactive and observables aren't that well documented, particularly channels aren't that well documented at the moment. So understandable if you want to stick with the basic version, and that's why I built it that way. Have a good one. Ta-ta for now.